Well, good morning to you each. I know that this is an important day, and it is our last section in Hawks to go over. I know you're very excited about that. It is section 8.1, Solving Systems of Linear Equations by Substitution or Elimination. This is the last section we'll do before our final exam. And some of you have asked, so let me just make it clear that the final exam is required of every student. When we started this semester, we thought we might have 3 tests and then an optional final exam. But in fact, we're only going to have the 3 tests, of which the final exam is the 3rd. So everyone will be required to take the final exam. The final exam is cumulative. That means it covers material from the first to the last. A review is online, and it is not required for you to do it. It is a voluntary thing, but suggested. This is a departmental generated review, which means it is not my review. I will be putting out a review early next week, and as the last review reflected the content of the last test, so this review will reflect the content of the final exam. Every question on the review, there will be a corresponding question on the final exam. So my recommendation to you is be very, very familiar with the review of the final exam that I'll put out next week, and you'll be on solid ground. All right, we're going to be solving systems of linear equations by substitution or elimination. In other words, we won't be using the graphing method, which we used for our last section. We're going to be able to do these problems without any graph paper at all, just simply using algebraic techniques. Let's look at these. The first is called substitution, and I'm sure some of you are familiar with these concepts. Choose the substitution method when one equation is already solved for x or y, or may easily be done so. Now check it out. One of these equations, here's my system of linear equations, one of them is already solved for x. Since that's the case, in the other equation, I substitute. I substitute y plus 1 in the place of x, since x is y plus 1. So I write 3x, but wait a minute, x is y plus 1 minus 4y equals 1. And I immediately see the benefit of this substitution method. Please note, I only have one variable. I can easily solve a linear equation with just one variable. Here we go. A little distributive. Like terms, this is negative y minus 3. So negative y is negative 2, which means multiplying both sides by negative 1, y is 2. So I already have the y value for my intersection of these two lines, solving the system of linear equations. So all I'm going to have to do is substitute 2 for y in either of these equations. This is the simpler of the two. So x is y plus 1, but wait a minute, y is 2. X is 3. So I have my solution, my point of intersection, the point 3, 2. Again, I choose the substitution method when one of the equations is solved for x or y, or may easily be done so. All right, second method, solving by elimination. Some of you may have used the term cancellation or addition method. Those are all names for this method. It says choose the elimination method when opposites exist or may easily be created. Now, when I'm talking about opposites, I'm talking about the y's or the x's. I can make opposites of those terms. If you look at these two equations, and by the way, this is an example from your last section. If you look at these two equations, I got some opposites with the y's. So since opposites already exist, I am simply going to add these two equations together. Now, to use the elimination method, the addition method, the cancellation method, whatever you want to call it, you have to have all your parts lined up. X's, Y's, equal signs, numbers. Why? Because I'm going to be adding them together. 4x and 4x, 8x, 2y, and its opposite, negative 2y. Oh yeah, opposites cancel. What we mean by that is they add to 0, and I'm not going to put plus 0y. That would be very confusing. So 8x on this side, negative 24, divided by 8. Oh my goodness, that was fast. And I have x is negative 3. So now all I have to do is substitute negative 3 into either of these equations. I'll pick the first one. 4x plus 2y is negative 12. But wait a minute, x is negative 3. Once you have one of the values, just substitute to get the other. Negative 12 plus 2y is negative 12. I think I'll add 12 to both sides. Oh my goodness, look what happens. 2y is 0, divided by 2, y is 0. So I now have my point of intersection, negative 3, 0. All right, so these are the two methods or approaches to solving systems of linear equations that we're going to be using in this section, either substitution or elimination. All right, here we go. Now, each of these problems, it says use the substitution method to solve, and then it has at the bottom, there's only one solution, it is inconsistent, or it is dependent. What in the world does that mean? Well, let me take you back to a graph that we used on section 8R1, our last section, and remind you that there are three things that can happen when two lines are on a plane. They can intersect in one point, typically happens. They can be parallel and miss each other altogether, in which there is no intersection, or they can overlap each other. This is actually two lines right here. They can coincide or overlap. One can sit right on top of the other, in which case there is an infinite number of intersections. Now these are what we mean by, is there one solution, one intersection? Is it an inconsistent system? Inconsistent means they are parallel lines. Dependent is another name for what happens when the two lines overlap. So these are overlapping lines. I will be including this sheet with my notes that I will post. So this is definitely something you want to have handy to identify what it means if there's one solution, an inconsistent or dependent system. All right, so let's see what we got here. Use the substitution method to solve. Hey, might as well, look here. One of the equations is already solved for y. So in the other equation, everywhere there's a y, I'm going to put what y is, namely 10. So instead of x plus y is 32, I'm going to put x plus 10 is 32. Subtract 10. Oh my goodness, that was easy. X is 22. Check it out. I've got my point. X is 22, y is 10. My point of intersection is 22, 10. And so I will choose only one solution, and as soon as I choose that, there's going to be a little box that shows up that asks me, okay, what is that one solution? It's 22, 10. All right, use the substitution to solve. Neither of these equations is solved for x or y. But please note that this one would be very easy to express as solved for x or y. All I have to do is divide both sides by 3, and I get x is 9. So very easy to solve this guy for x or y. And now I'm going to substitute in the other equation. Everywhere there's an x, I'm going to put a 9. Instead of 5 times x, 5 times 9, that's 45. Subtract 45. And I get negative 3y is negative 33. Easy to find y, divide by negative 3. Y is 11. So x is 9, y is 11. So again, I'm going to choose, hey, these have one solution. It is this type of scenario where they intersect at one point. And that one point where they intersect is the point xy, 9, 11. Not too bad, huh? Using the substitution or the elimination method. Okay, let's try this guy. And this says, hey, use either method to solve. Anyone, go ahead, I don't care which one. Use either method to solve. Well, I'm just going to show you that you can use literally either method. If some of you guys have preference for one or the other, by all means use that. For instance, in the last equation, in the last problem, it said use the substitution method. But if you are familiar with, best friends with the elimination method and you want to use it, help yourself. Either method works. So this is what we're going to do. We're going to use both methods here just to show you how they both work. Remember the substitution method. I use the substitution method if either of these equations is solved for x or y, or may easily be solved for x or y. Well, I see an x all by itself here. It's negative, but that's no problem. I can deal with that. But an x is all by itself, so I'm going to use this first equation to solve for x. Here's what I'm going to do. I'm going to move the negative x to the other side and change its sign. That means I'll have x by itself over here. I'm going to move the 9 to this side and change its sign. So I get 3y minus 9. So this equation, by moving the x and moving the 9, becomes x is 3y minus 9. Then in the other equation, everywhere I have an x, I'm going to put what x is, namely 3y minus 9. So I'm going to have 4 times 3y minus 9. That's what I have right here with this guy. In the place of x, I've simply put what x is, 3y minus 9. 4, that's 12y. And I get, let's see, I see some like terms, 12y minus 12y, that's out of here, and I get negative 36 equals negative 36. And I'm thinking, wait a minute, where's the x and the y? There's no x or y here. This lets me know that I'm in one of my special instances, either an inconsistent system or a dependent system, when the x's, the y's, when the variable disappear. This obviously is a very true statement. When I get a true statement, a number equals itself, and it can be any number. 7 equals 7, 14 equals 14, 0 equals 0. When I get a number equal itself, what I have here is an inconsistent what I have here is a dependent system. Number of intersections is infinite. Remember when we had instances when we solved linear equations and we got a number equal itself? We said the solution set was all real numbers. Well, if my intersection has an infinite number of intersections, that's another way of saying they overlap. This is a dependent system. Hey, the numbers overlap. The lines overlap. If I get a number equal itself, an absolutely true statement, that means there are an infinite number of solutions. My solutions are intersections. The only way I can have an infinite number of intersections is if the two lines overlap. So when the variable disappears, it's either going to be that or that. In this case, it's the overlapping lines. So I will pick dependent system here because they are overlapping lines. Let's see what would have happened if I had used the elimination method. Remember, the elimination method, I have to have opposites. And in the elimination method, I have to have everything lined up. Everything's lined up, but I sure don't have any opposites. Hey, but check this out. If this term right here were negative 4x, it would be the opposite of that. So with that in mind, I'm going to multiply every single term in the first equation by 4 to make that an opposite. Now, I can't just multiply one term or 1/2 of the equation. I have to multiply every single term by the same value. And I'm choosing 4 because I'm going to make some opposites here. 4 times that. 4 times that. So I made opposites. Write this one as before. And I go, what the hey? Everything's an opposite. That cancels. That cancels. I get 0. That cancels. 0. Look what I got. I got a number equals itself. I got a true statement. I got a number equals itself. Notice it's a different number, but it's the same thing, same concept. A number equals itself. Whenever I get a number equal itself, I'm going to choose a dependent system. All right. Onward. Again, use either method to solve. Oh my goodness, check this out. I don't just have x's and y's. I have x's, y's, and z's. Hey, the first thing I want to point out to you about this guy is there will not be one like this on the final. You have one like this on your Hawks, but there will not be one like this on the final exam. That is with 3 variables. Now, I'm still going to be basically doing the same thing. Here's what I'm going to observe. I see this guy has x's and y's. This guy has y's and z's, and this guy's got all of them. Here's what I'm thinking. If I can make this all one variable, I can solve it. And here's how I'm going to do it. In the place of x, I'm going to replace this x with something in terms of y. I can change this equation, x plus 4y equal 9, to something in terms of y. Let's go ahead and do that. I'm going to solve this guy for x. I'm going to move this to the other side. Negative 4y plus 9. So in the place of this x, I'm going to put this statement, which just has y's. So this will just have y's, just have y's. And if I can just make this y's, then I will be well on my way to solving this equation. So if I can solve this guy for z equals something in terms of y. Let's see how that's going to work. I'm going to move the y to the other side and change its sign. This is why there's not going to be one like this on the final. I don't want negative 2z, I want z, so I'm going to divide by negative 2. And I get z is, negative over negative is positive, so this is y over 2. Another way to say it is 1/2 y. Negative over negative is positive plus 1/2. So check it out. I have the x in terms of y. I have the z in terms of y. So I'm going to substitute for the x and for the z these statements in terms of y. That should give me a long equation with just y's in it. So negative 4 times x. But what is x? It's negative 4y plus 9. Minus 7y plus 6 times z, but wait a minute, z is equals negative 21. Kind of convoluted there, but here's what we did. We solved one equation in terms of y, the other equation in terms of y. That way I can substitute and just have y's in this equation. Let's do a little distributive. Six times 1/2 is 3. 6 times 1/2 is 3. Let me make sure I got that right. Positive 16, negative 3, 3. Okay, looks pretty good. So let's see what I got. I got like terms. Got a bunch of y's here. 3 and 16 is 19. 19 minus 7, that gives me 12y. I got minus 36 and plus 3, that's minus 33 equals negative 21. So I'm going to add 33 to both sides. And I get 12y is 12. Hey, y must be 1. So I've got 1/3 of my problem solved. I know what y is. Hey, but check this out. X is negative 4 times y plus 9. So I'm going to use this. X is negative 4 times whatever y is plus 9. But I know what y is. Y is 1. So x is negative 4 times 1 plus 9. X is negative 4 plus 9. That's 5. So x is 5. I've got x, I got y, now I just need to find z. I'm going to use this equation to find out what z is. It's 1/2 times whatever y is plus 1/2. But I know what y is, it's 1. So z is 1/2 times 1 plus 1/2. But 1/2 times 1 is just 1/2. 1/2 and 1/2 is 1. So z is 1. So check it out. I got x, y, z, 5, 1, and 1. So this has only one solution because I got x's and y's and z's. And in alphabetical order, 5, 1, 1. This is kind of like one of those Sudoku problems where you have enough to get a little bit, and then you use that to get a little more, and use that to get a little more. So keep in mind, though, there will not be one like this on the final exam, and you're welcome. All right. Let's check this feller out. Joe works 2 part-time jobs for a total of 31 hours a week. Job A pays $6 an hour. Job B pays $6.70 an hour. How many hours did he work at each job the week he earned $197.90? Round to 2 decimal places if you need to. All right. First concept, Joe works 2 part-time jobs for a total of 31 hours a week. Every week he works 31 hours. Sometimes it might be more at one job than another. It might be 1 hour at one job and 30 at the other, or 15 in this one and 16 at that one, or 5 in this one and 26 at that. It varies, but it's always 31 hours a week. So the first thing we're going to do is give ourselves some variables. X is the number of hours on job A, the first job. And of course, Y is going to be the number of hours on job B. Now notice, this is the number of hours he works at the first one, the number of hours he works at the second one. This total is always 31. He always works 31 hours at the 2 jobs. So I can write my first equation. X plus Y is 31. The number of hours at this job plus the number of hours at the second job is always 31. My first equation. Now, how is he going to get paid? Here's how you realize. Here's how somebody's going to get paid if they're working 2 jobs. First of all, the number of hours he works at a particular rate, that's how much he gets an hour. Like if it's 4 hours at $6 an hour, 4 times 6 is $24 he gets. Plus the number of hours he works and the rate at that particular. I could call it rate 1 and rate 2. Because the rates are different, $6, $6.70. So the number of hours he works, how much he gets per hour, plus the number of hours he works at the second job, times how much he gets per hour, equals the total amount he gets. That's what we got. So I need to fill in what I know. I don't know X yet, but I do know the first rate. It's $6 an hour. I don't know Y yet, but I do know the second rate. It's $6.70 per hour. And I do know the total. It's $197.90. So here's my second equation. Now I'm just going to go ahead and write this first one down underneath it. X plus Y equals 31. And here's my system of linear equations right here. Here's my 2 equations, both with the same variables. So using either the substitution or the elimination method, I should be able to deal with this guy. And I think since this equation will be very easily solved for X or Y, I think I will use the substitution method. So I'm going to move the Y to the other side. And I'm going to get X is 31 minus Y. And then in the other equation, everywhere there's an X, I'm going to put 31 minus Y. So I got 31 minus Y times 6 plus Y times 670. Notice I only have one variable, just Y is in this equation. That's the benefit of this method. And you're probably going to need your calculator here because you got some decimals going. So get your calculator handy. 6 times 31 is at 186 minus 6y, 6.7y. Okay, I got some like terms. 6.7y minus 6y is 0.7y. y. I think I'll subtract 186 from both sides. I get 0.7y is 11.90. And I'm going to divide both sides by 0.7. I find out that y is, hang on a second, 11.9 divide 0.7. Wonderful, I get a whole number, 17. That tells me that this guy, that Joe works 17 hours at job B. How am I going to find x? Well, here it is right here. X is 31 minus y, but y is 17. So x is 31 minus 17. X must be 14. So how many hours did he work at each job? Job A, 14. Job B, 17. And let me just go ahead and point out that there's not going to be a problem like this on the final exam either. You're welcome. All right. Going on to this feller. Use either method to solve. Okay, I got my system of linear equations. I'm giving the choice of using either method. And I make a little observation here. Hey, look at these guys. If I multiplied this by 2, I'd get the same as that. If I multiplied it by -2, I'd get -6y, which would be the opposite of that. So I'm going to choose the elimination method because this is going to be very easy to make some opposites with. I'm going to turn this into -6y, which means I have to multiply this entire equation by -2. -4x minus 6y, -42. Okay, I'm ready to do my elimination method, which means add the two equations. That obviously cancels. This gives me -x, and this gives me -6. If -x is -6, then x must be 6. Well, that was pretty easy. Already got my x. So pick either equation. I'll pick this second one here. And substitute 6 for x. So in the place of x, (18 plus 6y is 36. This is going to be easy. Subtract 18. Divide 6. Y is 3. Well, that worked out pretty nicely. I recognized that by multiplying this equation by -2, I could make opposites. So I made some opposites, added them together, and bingo, x is 6, y is 3. If I get x is something and y is something, it's always only one solution, and that is the one solution, 6 and 3. Not bad at all. All right, this guy says use the substitution method to solve. We're going to solve it by both methods just to familiarize ourselves with the idea. The substitution method says I need to solve one of these equations for x or y. Hey, look at that guy. It's already got 1x right there. This would be very easy to solve for x or y. So by moving the 5y to the other side, I get x is 14 minus 5y. Then in the second equation, everywhere I have an x, I'm going to substitute 14 minus 5y. So instead of negative 3x, negative 3 times 14 minus 5y. Let's see. Negative 42. Negative times negative is plus 15y. Minus 15y. There's another one. Equals negative 42. Uh-oh, something's going to be afoot here. Check it out. The y's cancel. And I get negative 42 equals negative 42. Hey, remember this scenario? I get a number equals itself. You remember what that's the example of? That's an example of a dependent system, when I have a number equals itself. So I'm going to choose dependent system. Well, let's use elimination and see if we get the same thing. Remember, you are free to use either method at any time. Elimination method is where I look for or create opposites. Don't have any opposites, but I can sure make some. If this were 3x, it'd be the opposite of that. So I'm going to multiply this top equation, every term, by 3. And I'm going to get rewriting this guy. Not only do I have opposites, but well, you know, everything is an opposite. Opposites, opposites, I get 0 on this side. Opposites, 0 on this side. Notice what I got? A number equals itself. A true statement. Whenever I get that true statement, that tells me I have a dependent system. The two lines simply overlap. All right. Last one coming up. This is exciting. Our last Hawks problem of the year. Use either method to solve. Okay, you go. Either method. If I solve this for x, I get a bunch of negatives. Oh, I think I'm going to use the elimination method. And here's why. If I multiply this by a negative 4, I will get positive 4x. So I want to make an opposite of negative 4x, which is positive 4x. And to do that, I have to multiply my top equation by negative 4. Why? Negative 4 times negative x is positive 4x, the opposite of that. So I get 4x, negative 4 times negative 4, plus 16y. Negative 4 times negative 14 is positive 56. Rewrite this one as it is. Got me some opposites, so I'm ready to add the two equations together. Add them up. Cancel, cancel. I get 0 on this side. 56 minus 55 is 1. Look what I got. Since I have no x's or y's, I know it is one of these two systems. But this is not a true statement. This is, in fact, a false statement. Whenever I get a false statement that does not involve a variable, 0 equals 1, 3 equals negative 2, 7 equals 19, something like that, a false statement, that tells me I have an inconsistent system. Remember when we solved equations earlier in the year and the variables disappeared and we got a false statement? Our conclusion was no solution. Remember that? But my solutions in solving systems of linear equations, my solutions are intersections. So another way of saying no solutions is there's no intersection. Well, how can you have two lines with no intersection? I think I know. Parallel lines. No intersection, no solution for the system, inconsistent system. So I will choose inconsistent system. No intersection implies parallel lines. All right, just again a review. If I get two numbers, no variables, if the numbers are different and I get a false statement, since 0 is not equal to 1, I have an inconsistent system, I have parallel lines. If I get the same number, 5 equals 5, 0 equals 0, I have a dependent system, I have two lines that overlap. All right, I'll try to get these notes posted visibly online for you so you can run them off, and I will try to get the test review online as quickly as I can so that you can have maximum number of days to study for it. The review will be online, and you will have basically 4 days in which to take the final exam. If your final exam was scheduled, let's say for Monday, then you will have 4 days before that to lead up to that Monday due date. So you'll have plenty of time to do it. You'll also have 2.5 hours for your final exam. More than enough time that you'll need. But remember, this is uninterrupted. What that means is once you start, you have 2.5 hours to finish. You cannot stop and come back and go eat lunch and come back and take a nap and come back. You have 2.5 hours of uninterrupted time once you begin the final exam. What else about the final exam? As soon as it's finished, you will have your grade visible, and as soon as I can average all the grades, the test you took when we were in normalcy, all the daily work that you did when we were in normalcy, I will have all that averaged, and I will put your final grade, make it visible for you. All right. Well, good luck to you, and see you for the final exam.